Hello, everyone. This is Energetic Emmanuel coming to you guys. Doing what we do. Math, Algebra 1. Here we go. I gave you guys a packet on the other day. Look, on the other day, which was the 19th on the other day, yesterday, okay? I gave you this packet, Algebra 1 here at South GP 9th Grade Center. And I'm going to continue making videos of it. I'm going to try to limit it to like no more than 8 minutes at a time. Or should I say 8, 9 minutes, okay? Let's try to keep it less. So I'm going to make more than one part. So here we go. We're first talking about multiplying polynomials in this series, if you will. So we're multiplying polynomials. And that we already added and subtracting polynomials, which means combining like terms. So now we're going to multiply polynomials. How are we going to do it? With this lovely distributive property. Okay, so we're going to use the distributive property, and to organize it, we will also use a graphic organizer sometime. It does. If you want to use it, you can use it. But we're going to use graphic organizer to multiply the polynomial expression, and we also will use the distributive property to multiply expressions. I'm going to just flip through here, these packet, and go to page, and I'm doing this so that you can see what I'm doing here. I'm going to go ahead and go over here to page 374, about 374. And here we go. So now if you lose your pack or anything, you can see this. So you pause the video. That's what I love about it. So when we're multiplying it, it's really just multiplying it. Okay, distributive property. Here in this graphic organizer, they want to start off in this springboard journal. It said you can use the same graphic organizer to multiply binomials. And they're talking about it's already been used. I'm not going to go through the part. You're doing that on your own. Okay, you can use the same graphic organizer to multiply. So what are we going to do? Multiply. Okay, binomials, you know, is two terms. Okay, that contains variables. The following diagram representing, here's the binomial. That's 1, 2. That's two terms. 1, 2, two terms. So we're multiplying binomials. We separate this so that here you got x minus 2. This, let me use a different color. You have your x minus 2. And so this represents x minus 2. Here, this factor here is x minus 3. And they wrote the factors here. Okay? And they split it into terms. So how this works, we're going to say x times x, and it goes in this first rectangle. Okay? So x times x. And I'm going to actually write that out. X times x. Okay? Same base multiplication. What do you do to the exponent? That is 1 right there. We don't write the 1. So we keep the base the same. We add the exponent, which will be 1 plus 1, giving us 2. So that's x squared. Then for this rectangle, it's going to be it's going to be x times negative 2. So it's x times negative 2. The coefficient of this x term is a 1. So we multiply the coefficient with that constant. So we have 1 times negative 2, which is negative 2. Yes, you have to place your x there beside that numeric factor, negative 2. Now, we're going to say negative 3 times x. So negative 3 times x is just negative 3x. Here, we're going to say negative 3 times negative 2. A negative times a negative is a positive. 3 times 3 is 6. We have now, right here, we have 1 term, 2 term, 3 term, 4 term. And you probably said, do we have like terms? Of course. Let me write this out horizontal. So we have here x squared minus 2x minus 3x plus 6. Here, the two middle terms are like terms. And let me go ahead and color code this right here. They're like terms because both has an x to the first power. And I'm going to write here like terms so that just a reminder. Those are like terms. Sorry, guys. Let me rewrite that. Let's do this like this. Like terms. Okay? So with like terms, we add or subtract the coefficients of the variable. Bring down the x squared. Okay? This is a -2. That's -3. -2 combined with -3 gives us a -5. The x, you do not add the exponent because you're not multiplying. Okay? So we just bring the x term down. The constant has nothing to combine it with, so bring the constant down. So now we have x squared minus 5x plus 6 is the product of these two binomials. Are we done? Let's check to see if it's in standard form. Standard form, recall standard form is when the highest exponent goes first, okay, in the polynomial, and it decreases as it goes to the right. Okay, so we have x squared, okay, x to the first, and we have x to the 0. And you be like, we don't have x to the 0. Yes, we do. 6, and let me, look, y'all, I gotta get all cutesy. 6 is the same, 6 times x to the power 0 is the same as saying 6 times this x to the power 0 is 1. So 6 times 1 is just 6. So if you hear me saying the x to the 0 term, I'm referring to the constant. Okay. So are we done with this? Yes, we're done. Okay, with this part. Here is the use the graphic organizer above to use the graphic organizer above to represent the expression x minus 2 times x minus 3, the binomial. We already did that, correct? Yes. However, it said label each inner rectangle and find the sum. We did that. Okay? We have here our leading, oh, this, guys, is some, let me write this down for you. So if you're using this graphic organizer, this nice little rectangle, or look like a window pane, right? Here, no, this is going to be your leading term. That'll be your leading term. This would be your last term. I don't want to say constant because what if it's a variable there? That'll be your